Good morning, everyone. Welcome to our webinar on PCI compliance strategies in Amazon Web Services. Thank you, everyone, for attending. We hope you find this useful. We'll be monitoring questions that you could provide through the web meeting interface, and we'll do our best to address those based on the time we have at the end of the presentation. And those that are not addressed, we will follow up with you online. So please don't hesitate to reach out to us with any questions during the course of this presentation. So sorry here. So let me start with some introductions. My name is Adam Gatosh. I'm the Director of Security Intelligence here at Anitian. I'm a QSA. I've been so since 2008. So quite a bit of PCI work amongst many other aspects of InfoSec in my tenure here at Anitian and previously in the defense contracting world. And we've been working with AWS as a partner of theirs for the last 4 or 5 years, primarily on PCI work with them and for them, including a workbook that they sponsored us to write, of which we are releasing the 3rd annual revision, and they are publishing on our behalf and in tandem with reInvent this month. And so the intent of this presentation is to give you a preview on that. I'd like to introduce my colleague in this presentation, Jordan Wiseman.
Good morning, everybody. I'm a Senior Security Intelligence Advisor with Anitian. I'm also a QSA. I've been working on PCI stuff and compliance for a number of years in security since really since the late 90s. My time split about half and half between healthcare and those unique privacy and security concerns, and then general business and privacy. So I kind of see things from both sides there, both security and essentially the privacy piece when it comes to compliance.
Okay, so here's just a brief overview of Anitian's practices that we have. We have 5 core practices that we offer professional services within. Risk Now is our rapid risk assessment practice, some supporting services there you could see. Vision Path is our compliance. We do audit, assessment, advisory work for a range of standards. Obviously PCI, what we're talking about here, falls under that. Ring Zero is our security testing, a lot of pen testing work and other things. Pretty active on the blog that you can see some of the work that team is doing. Our Sherlock practice is our managed security practice that we've really been excited about the growth of the last few years, managed security operations and MDR and other supporting services. And then vCISO, which is really at the heart of what we do as security advisors, leadership as a service, helping drive vision for security departments. So that's just a basic overview of what Anitian does. Let's dive right in, though, to the presentation itself, if we may. So as I alluded to, this is to discuss PCI compliance strategies at AWS. This is going to be a preview of the 3rd annual publication that Amazon will be publishing of the white paper that they sponsored us to write for them as QSAs, demonstrating our expertise on PCI and explaining how you can leverage the various AWS services to deploy PCI compliant environments.
So one of the things with that we're going to talk about today is the services that are included and covered by AWS as far as things that are able to be compliant while you're using them in the cloud, as well as some additional strategies on how to meet specific PCI requirements with AWS services that new services that they're offering and things not necessarily included in their own PCI assessment.
That's right. We are going to, of course, go over the whole general approach that we recommend and discuss in greater detail in the workbook, but we're going to make sure that we emphasize in today's presentation some of the new strategies we recommend in support of the newly deployed or in-scope services that AWS has in this most recent compliance cycle that they have, which is an annual cycle. Every year it's published in the summertime, the list of services that are included. There's always lag behind those, which are being developed and deployed by Amazon, those are what you're brought into their assessment scope as a service provider. And so we'll be emphasizing those. So that's a good segue into understanding a little bit about AWS, their compliance status, and how that pertains to users of AWS. So
I was going to say that last bullet point is really kind of important. So AWS is certified as a level 1 service provider. A number of their services, a lot of the usual suspects and the things that people care about, you know, DynamoDB, EC2, S3, they're covered by and assessed every year as part of AWS's own compliance efforts. However, what you build on it, you still have to make PCI compliant, and that's a really important note that gets into segues nicely into our upcoming discussion in the next slide about the division of responsibility.
Yeah, the only thing I would note here before we move forward is that there's been a slight change this year with how you can get and request the compliance documentation that Amazon has for their services. It used to be that you had to email them and NDAs and such. Now they have a service within the EC2 console of AWS called Artifact that has all of their various compliance documentation available on demand, direct, without any type of lag.
Right. So everything you need is in there, not just PCI, but they've got SOC, they've got other stuff in there. A couple of them will still have to go through a request process. In other words, you click the link, it'll take you to a form where you let them know what you're asking for it for, and you agree to keep it confidential. But it's a much more streamlined process. Any of the needs sorted by standard are included in that Artifact service, and it's available in the console just where all the rest of the services are.
The PCI documentation is available direct. Now, I'd also just note that the responsibility matrix, which delineates for each PCI requirement, which aspects of that requirement are covered by their audit versus are the responsibility of a user of that service. They really spent a lot of time. We were fortunate to be able to help them on this most recent effort to update and enhance the information they're providing in that responsibility matrix. So that's a really useful work product to understand the difference in responsibilities for users, which...
Yeah, the responsibility matrix can give you a really clear picture of what you need to do to build. You know, I mentioned if you're building a service or deploying something on AWS, you still are responsible for deploying it in a compliant fashion, and that responsibility matrix can help you really determine what that plan of action looks like, what you need to do to actually make sure that your systems are at least that you're taking care of the additional requirements, not necessarily automatically handled by AWS. And that gets back to this concept right here. And this is important not just for AWS, but for any cloud service provider you use. And that's this idea that there's a shared responsibility for what you do with the cloud versus what the cloud provides you in terms of not just services, but security and compliance.
That's right. And I would extend this concept, frankly, to any service provider, be it cloud-based or something more traditional. But at the end of the day, it's important to understand that the difference between the security in the cloud
and the security of the cloud.
That's right.
AWS provides services, you know, that traditionally they've been more of an infrastructure as a service provider, but they offer a lot of other services that you could consider, you know, platform as a service, things like RDS and DynamoDB, or even software as a service when you get into things like Amazon Connect and that kind of stuff. And these are platforms that it doesn't matter what the actual model is for it. The idea is that they are responsible for the service itself and the infrastructure of the cloud. You're responsible for what you do with it and what you put in the cloud. Okay, so next we'd like to move into an overview of the AWS compliant PCI services, which we've mapped to the different PCI requirements, and talk about different strategies you can use to meet the 12 top-level PCI requirements. So starting with number one, the first PCI requirement broadly is your networking architecture, how you are segmenting your environment and enforcing access control. So the most important thing to gather from this related to an AWS deployment is the understanding that virtual private clouds are private networks. If you create a VPC within your Amazon account, it is a private dedicated network that you can use for sensitive data, customer only data, and it's considered private from a PCI standpoint. Not even the Amazon folks have access to what you're doing inside of a VPC. They've engineered it that way on purpose.
They're isolated by default.
Right.
So commonly you'll see entities deploying different VPCs that, for example, maybe production versus development, that type of thing.
In fact, by default, so when you deploy a VPC, there's two ways to do it. You can build it, from scratch if you know what you're doing, or they have a couple of wizard-like things that will walk you through some common scenarios. By default, VPCs don't even have an internet connection. You have to actually create and attach an internet gateway. A couple of the scenarios you can build out through their wizard will include one. It'll be obvious which subnets within that VPC afterwards are what they call a public subnet, which means it has an internet gateway and the potential to talk to the internet. Versus private, which is fully contained within the AWS account and potentially within just that VPC itself. It's also worth noting that having an internet gateway doesn't mean that you can talk to the internet. It means you have the potential to. Just because you have an internet gateway doesn't mean you have a public IP, for example. And it doesn't necessarily mean that you have a route out to the internet. Those are other things that have to be set up within the system.
And as we talk further about automation and some of the PCI reference architectures, we'll mention CloudFormation, which is a deployment service that they have and a new product that we're really excited to launch, and we'll talk about later here, that can build out the PCI reference architectures for you in an automated fashion as a baseline to accelerate some of this cloud deployment.
Oh yeah, and CloudFormation takes that whole idea as software as code, right, or infrastructure as code, where you define everything that you want to build on AWS as a JSON file or as a for another language, YAML file. I think.
Yeah, YAML.
And it's nice because it gives you opportunity to vet the design and configuration before you actually roll it into production, or to quickly, remove or deploy new environments as you need to, making sure that all the pieces like your segmentation and VPCs are intact. CloudFormation templates can build new VPCs and configure them the way that you want to do for compliance purposes. Now, the other key aspect of requirement 1 is how you actually provide that network segmentation. So we talked a lot about how VPCs are private networks, but you still have to configure firewall rules and the routing configuration between subnets within those VPCs in order to ensure that your environments are isolated and properly segmented. Amazon provides some native ways of doing a lot of that. So security groups is one, probably the most common and most important service to note. It's a function of EC2 virtual private clouds. They are stateful, rule-based firewalls that you can apply to groups of instances. Instances is the AWS term for a running. Virtual machine is not really the right word because it's not just VMs. Any service that you're using within AWS is instantiated as an instance. A lot like creating instance of classes in code, which is kind of where the term came from originally.
So, for example, an instance might be an EC2 instance, which is the equivalent of a virtual machine, or it might be utilizing one of their platform as a service, such as an RDS database instance.
Exactly.
Both of those are effectively objects with IP addresses that you could establish access control on via security groups.
Exactly right. And the security groups, the nice thing is they're stateful, they're rule-based, they can be used to meet PCI requirements, and they can be controlled via CloudFormation templates and scripting and code automation and a lot of the other stuff that we're going to talk about later. Network ACLs can be used to help provide segmentation, but they are not stateful. I don't know if anybody remembers configuring firewalls 20 years ago where you had to create rules for traffic both inbound and outbound, and if the rules had to line up, and it became a huge mess if you couldn't predict what ports communications were going to occur on in IP. Network ACLs, configuring them is a lot like that, but they're not stateful, which means they can't alone be used to meet your PCI firewall requirements. So some strategies and considerations about these deployments. So aside from using native security groups, which are scalable and automatable, there are third-party Amazon machine images that you can get from the AWS Marketplace that allow you to deploy traditional firewalls you're familiar with. So if you like FortiGates, or you like Sonic Walls, or you like Palo Altos, there's virtual images for all of those. They're manageable the exact same way you're used to with all those other systems. The caveat is they are themselves instances within AWS, so you have to ensure that traffic gets routed through them for them to be effective. And scaling them has to be taken into consideration with the rest of your infrastructure, which leads us to that other consideration. If you're in an environment that's highly dynamic and you could scale up from 10 to 100 or 1,000 instances as demand requires, that might be difficult to manage with a traditional firewall. So in that case, you can rely on security groups and make it as part of your configurations, whether you're using auto scaling or CloudFormation or whatever, to ensure that you're adequately protecting your VMs and segmenting them, or you can rely on host-based agents you include within your customized AMI. So this is relying on the built-in Windows packet filter with group policy to control the rules or bake the rules in. This is relying on IP tables for Linux instances or packet filter rules for BSD instances. Whatever you rely on, there's even third-party agents you can deploy. The semantic endpoint protection, for example, if you're deploying its agent and you're going to use its firewall capability and manage it centrally, that's an option. The nice thing about the host-based stuff is you have as many of those in place on every host that you've got that scales with your hosts and can still be centrally controlled.
Okay. So the next requirement here, requirement 2 for PCI, is effectively your host hardening requirement. Secure system configurations. So one of the things that you might notice here, just for some nomenclature throughout this presentation, when we list AWS services that might be used to support a given PCI requirement, the ones that are in italics are the services that are new to Amazon's compliance scope for 2017.
Right. Now, they're not necessarily new to AWS. Many of you may already be using these services, but it's nice to know that they're now included in AWS's compliance efforts, and the management of those services, or certain aspects of them anyway, are covered by Amazon's Attestation of Compliance, which just makes demonstrating your own compliance to your QSA easier. So with requirement 2, key things to note here is Amazon supplied AMIs have no default credentials. So if you use Amazon Linux or if you use their supplied Windows instances, the default usernames and passwords for those systems are random, and there's nothing you have to worry about. Third-party AMIs may still have default users. If you deploy one of those firewalls we mentioned before, if it's a WatchGuard AMI that you're going to put out there in your environment, it's still going to have the default passwords for WatchGuard that you might have to take care of. That's just an example. I know the newer versions of fireware are a little bit better about that, but it's just an example. And there's the pre-hardened AMIs available in the marketplace too. These are pre-built AMIs that include the hardening steps. There's a few vendors out there that have them. We have them, in fact, Anitian does, and one of the nice things about ours is the instances that you get from us that are pre-hardened for PCI compliance also include documentation of all of those steps. So not just do they come out secure out of the box, but they include all the stuff you need to demonstrate what was done to make them compliant.
And so another thing, of course, as we're getting into more infrastructure as code, you're seeing a greater adoption of container-based deployments, and so OpsWorks stacks will support that, much like Kubernetes or Docker Swarm for Amazon containers.
Yeah, and we didn't list it under AWS Services here, but Elastic Container Service, which is their managed container platform, is covered in their AOC now, right?
Yeah, that's right. It's a Docker equivalent, effectively, and so that's certainly a strategy that we're seeing our clients adopt to embrace the idea of disposable IT, right? Where you don't patch, you just push a new container.
Yeah, more and more folks are moving to that microservices architecture, and we can talk a little bit more about Lambda and stuff later, but those are services that are included now. Other things to mention are CloudFormation and OpsWorks allow you to automate the process of standing up full application stacks and solutions on the fly, and you can, because they define the infrastructure as code, you can link them to things like the pre-built AMIs that you know are secure and compliant, that you've already documented, and it can provide ways of ensuring that your application stacks are built using the known good resources you've already set up and can trust for your own compliance efforts. So it's a way of ensuring that what you need to be compliant really will be when you turn your stakeholders and end users loose on the environment.
Okay, I guess the other thing I would just mention here is that we're also getting into the concept of the disposable IT and infrastructure as code, tying into either with EC2 itself or instances, or when you're using containers, is a lot of adoption of some of the configuration management platforms out there to do host hardening in a centrally managed fashion, such as Chef recipes, for example, or Ansible, or some of these other technologies that are out there.
Yeah, in fact, OpsWorks itself is built around Chef and a few different versions of using Chef. It's possible to use Ansible to do automation within AWS. Also, it's not supported as a hosted service just yet, although they're heading that direction, as I understand it. But for right now, like when you do OpsWorks stacks, you create repositories for your Chef recipes, and you can have AWS actually manage the execution of those recipes for you.
Okay, moving on, we've got a lot of content here. So the third requirement in PCI is cardholder data at rest. And so, effectively, these are the encryption requirements for stored cardholder data. Of course, one of the primary mechanisms for reducing the scope of PCI and reducing the risk of a compromise to an entity is to reduce or ideally eliminate the storage of cardholder data. But in practice, obviously, that's not always something that aligns with the business needs. So it's not uncommon to have to store cardholder data in some mechanism. And so there are quite a few different storage services that AWS offers, which can be leveraged to ensure that you are storing cardholder data in alignment with the PCI DSS. So we have EBS, of course, which I really think of basically as your hard disk equivalent, if you will. You have a simple storage service, which effectively would be like their file server equivalent.
It's the underlying store behind most of the Amazon storage platform, frankly. And the big advantage for requirement 3 is that S3 buckets and the other things you create are not like EBS volumes and volumes related to Elastic File Store and RDS database instances, Redshift, data warehousing instances. All this stuff can be encrypted at rest, essentially using a checkbox. Now, there's a couple of things before checking the box you'll need to do, like go get keys from the key management service, except for EBS volumes, which can use their own, and S3, which can use its own also. But the point is you can literally check a box for those things to enable encryption and make sure it's encrypted at rest. There's a couple of things worth noting here, keeping in mind. The first is that if you're encrypting EBS volumes, so these are the underlying, like Adam said, the hard disks that you would connect to your instances for typical local storage. Access to those encrypted volumes is not independent of the operating system, which means if you attach an encrypted volume to an instance that has access to the key, then nothing will prevent processes running on that instance from getting at that encrypted volume. So by itself, that might not be enough, depending on how you've architected your
PCI explicitly requires, if you're using full disk encryption as the mechanism, it has to be independent of the operating system.
Right, and the idea there is that it's kind of a little outside the scope of the AWS stuff, but if like you had encrypted a laptop or something and somebody stole it, if all I have to do is turn the laptop on to get access to the data, then it's not really giving you.
Yeah, the encryption's transparent versus like some type of encrypted container on the file system.
Yeah, or how like File Vault in a Mac requires boot authentication, or how you can enable that for BitLocker for Windows. Same idea. There's a reason you have to turn those things on, right?
Yep.
The other thing is that self-managed databases. So if you deploy your own instance of Microsoft SQL, Oracle, MySQL, Postgres, whatever, I mean, those are all relational. There's no SQL stuff too, like Mongo and Couch and all that. You have to encrypt the data. They're not going to do that by default because, unless you encrypt the underlying storage platform, like this support native interaction with S3 or something. One key thing to note on here is DynamoDB, which is an awesome solution from AWS, and lots of folks are using it. DynamoDB doesn't yet support, checking that box to enable encryption at rest. So you have to encrypt the data before you store it in DynamoDB. You can either implement that within your own applications, or you can rely on the AWS. There's a client encryption library that you can use that allows you to sort of leverage KMS and some of the other encryption services to get to encrypt the data and manage it in there. But it is still something that you have to do. It's not Dynamo's not going to do it for you.
Good point. And Dynamo is their NoSQL database platform as a service offering.
Yeah.
Although, as you've noticed, the focus of this presentation is not necessarily on the service functionality themselves, but we're reference them where they might be uncommon. And so I would just note that KMS, which is the primary mechanism for managing encryption keys used to encrypt data on these different storage services. Another one that's not listed here because it uses S3 as the underlying mechanism, for example, is Glacier, which is their long-term archival and storage, right? KMS really makes it super trivial to implement key rotation, which is one of the big, sometimes it's a obstacle for clients of ours to implement when they have legacy database applications that they're using. It's as simple as a checkbox in KMS. Very nice.
And the only caveat there is to make sure that use of key rotation in KMS aligns with your policy. So PCI requires that you demonstrate that you're rotating your keys at whatever your defined crypto period is, right? So if your privacy or if your encryption policies say that you rotate private keys every 6 months, every 24 months, whatever, that's what you need to demonstrate. KMS doesn't give you an option as far as a crypto period. It's once a year.
That's right.
So if your policy says you do it every 6 months and you're really using on KMS, that might be something we actually need to modify that policy, or hopefully really just standard in your environment to say that, you know, it's 1 year so they're consistent is all.
That's a very good point.
There's also Cloud HSM, which lets you give access to your own dedicated high security module. It's a physical appliance in the cloud managed by or hosted by AWS, but managed by you effectively for managing and storing those encryption keys.
Mm-hmm. And I would just point out that CloudTrail, which is their logging, you know, effectively like their syslog implementation, logs all of the various key management encryption, file system access activities.
Key management and key use,
yes,
which can be separately defined permissions within IAM also. You can give people the ability to rotate and revoke keys, but not use the key to decrypt data if you really want to, which is kind of a neat, you know, added.
Exactly. IAM being their identity and access management service, which we'll talk about here moving forward. Okay, so requirement 4, we talked about data at rest. Now this is data at transit encryption requirements. Over public networks, just as a minor aside, it does not, PCI does not explicitly require that you are encrypting the transmission of cardholder data between networks within your assessment scope, for example, from like your web tier to your app tier to your database tier. It's certainly a best practice, but PCI focuses on open public networks, as you can see there by the top level definition.
And so a good thing to note here is when we talked about VPCs before being dedicated private networks within your environment, you do not need to encrypt communications between subnets within a VPC, even potentially within VPCs you own, or even between VPCs and your corporate environment if you're using direct connected VPNs to establish those communications. You do need to encrypt data between those VPCs and the internet or other networks you don't control.
Right, although there's so many services that AWS provides that would support pretty trivial implementations of transit encryption amongst different VPCs and different subnets and security group objects within your VPC. It's certainly a recommendation regardless of PCI's baseline. As we all know, compliance does not necessarily equal security. It's certainly a great starting point, but we always encourage you to leverage it as a baseline when possible.
Right. Now, I think certificate managers actually is included in their PCI scope now, right? I think we probably should have moved that bullet point up. Certificate manager is AWS's managed service for handling SSL certificates for things like their load balancers, and you can configure it on instances running web servers and that kind of stuff. It automates the process of managing those certificates. The largest benefit from it is it manages certificate renewal for Amazon services that it integrates with, which means you don't have to worry about, you know, when they're going to expire and making sure you get that stuff in time. You can just let certificate manager deal with it for you. A lot of the AWS services listed here are things that you can use that will help you ensure use of encrypted services, but just because you've used them doesn't mean that your data is encrypted. Elastic Load Balancers is a great example. You can use a load balancer as a SSL or TLS termination point. In other words, it can have the certificate and be the point where the encryption ended there, but it doesn't have to be. Its biggest value in this one is making sure that client communications are only really possible with your backend systems using, you know, HTTPS, you know, or TLS or SSH or other encrypted protocols. Making sure that unencrypted versions of or unencrypted protocols like HTTP over port 80 or TCP over port 80 and you know, God forbid, telnet, are not available to the outside world.
Okay. And I would just, as a reminder, that the grace period in 2018 will be expiring, the PCI grants for the use of early TLS and SSL. So if you still have that and we're getting through your assessment last year using a documented risk mitigation and migration plan, depending on your timing, when that grace period expires in June 30th of 2018, if I recall correctly.
You have until 1 July 2018 to use early TLS, then it's got to be gone.
So I would get ahead of that now, and of course, if you're a service provider, you already needed to be offering.
So the other thing to note here real quick that's really important is that communication between CloudFront and your VPCs, it goes across Amazon's border network. It's public, so you do need to encrypt between CloudFront and source systems. That's also true if you use S3 public endpoints. S3 allows you to create endpoints within your VPC for accessing data, but you have to use those to not have to encrypt your data transfers back and forth. That said, all the API calls into S3 are TLS encrypted anyway.
Okay, great point. All right, let's keep it moving here. About halfway through time-wise, make sure we can cover everything. So requirement 5 is the antivirus requirement for PCI, and
AWS manages antivirus for the infrastructure, but not for your instances and what you put on it. You need to do that. If you're going to run full operating systems in an instance, then you need to run anti-malware solutions on those operating systems. PCI has a thing about operating systems not commonly attacked by malware. I'm not sure there are any in general use anymore. Mac's commonly attacked now. Linux is commonly attacked now. Windows obviously is attacked now, unless you're running like cubes or something.
Yeah, I find it a hard sell myself. I always suggest to any clients that are trying to advocate that perhaps one of the operating systems they're using is not commonly affected by malware and therefore does not need to have it per this requirement, that they address that explicitly in the risk assessment that they're required to perform on an annual basis. It demonstrates that due diligence and underscores the fact that in spite of how prescriptive PCI seems on the surface, there is a degree of risk tolerance there to take a risk-based approach, but it has to be formally defined.
When you can't just say you can't just set that once and forget it. The risk assessment process has to show that you reevaluate that to ensure that it's still true at least every year.
Yeah, that's actually an explicit requirement of 5 as well if you do exempt.
Right.
The risk assessment is the appropriate mechanism in our opinion. So bottom line, these are going to be third-party solutions that you're going to be running in host-based AV in almost all instances. So requirement 6, this is a bit of a catch-all requirement in my opinion. It has your vulnerability management program and patch management requirements, and then it lumps in change management, secure software development. And so one of the things that we're really excited to talk about today and give everyone a preview here before it drops at reInvent in the end of November is we've been working with AWS's professional services to develop config rules. So rules are a subservice of AWS config.
All right, so config is an AWS service that allows you to monitor for changes within your AWS environment. So not what's going on with the operating systems you've deployed in instances or inside databases, but your use of AWS services themselves, how you've set up security groups, how you've set up IAM, what instances you're running, how they're configured, that kind of stuff.
Which is great. It really gives you some automated visibility to change control and change monitoring. But then a subservice of that actually functions independently of what config might be monitoring, and that it's not dependent, are the rules that they have. And rules, these are effectively, you could think of them as scripts, which they are, that run to check on really whatever you want. It's fully extensible. They have managed ones that they provide, and then they have an interface for you to make custom rules. Right. And so we've been working with them to have what they're calling compliance as code. And so they are writing rules that are checking for specific compliance requirements. One of the first big rules they had is for the AWS CIS benchmark. Again, this is at the AWS EC2 level that this CIS benchmark applies to. CIS benchmarks are the Center for Internet Security's host hardening standards, if you will. They wrote one for AWS at the EC2 level. Then AWS Professional Services wrote a config rule that checks for the implementation of all of those requirements.
All right, and there are things like, do you want to have a rule positively making sure that you don't have a security group that's overly permissive or something.
Is encryption enabled in RDS, that type of thing?
Or any other service where you could enable encryption. You can write a rule to check to make sure that it's there. And the value for that is there's really two key things you get from it. One is you get the ability to generate a list of artifacts for auditors that say, look, all this stuff that we say we had to do for PCI compliance or that's our responsibility, we can positively validate that a lot of it is already taken care of and generate the artifacts for that. The second thing you get for it is positive alerting when something changes. If somebody goes in and unchecks that box to decrypt or well, not decrypt, but to create maybe an instance that's not encrypted like it should be, or a security group that doesn't meet your standards or whatever, config can notify you that, hey, you've got something here out of spec and you need to take care of it.
So the existing rules that they have and are going to be published, those are all mapped in our workbook to the PCI requirements that they can be using to validate. To be clear, these would be intended primarily to use for validation and preparation for an audit. But the fact is they're a really valuable tool. We're really excited and proud to be part of that effort. And we're working with them to publish by reInvent this year a set of PCI specific ones. But just to be clear, the workbook delineates all of the existing ones to PCI requirements independent of the custom set that we're building to package those up for PCI. So
some other AWS services that apply here. So 6 also covers custom software development. So AWS is a whole suite. I mean, as you can imagine, Amazon, one thing they do really well is write code and manage the processes for writing code. And they've exposed a lot of customer versions of those tools, things like Code Deploy, Code Pipeline, Code Build, Code Star. These are services you can integrate into your software development processes to help demonstrate proper workflows, that you're getting approvals for releases of code, that code's being tested during the build process through the pipelines, that only certified code is deployed to instances and that kind of stuff. Those are all services you can use. They're not necessarily themselves all covered directly under Amazon's AOC, but there are things that you can do to help ensure your own services are meeting the standards according to your policies and processes necessary for compliance. AWS also provides a WAF. So requirement 6.6 says that you have to, for any custom developed web applications, you have to, or any internet-facing web applications, you have to either do security reviews of the applications, or you have to put a technical solution in front of it that can block known attacks. AWS provides a WAF that meets that requirement. You can put that WAF in front of content you're hosting in CloudFront or web servers that you're locating behind an application load balancer. There's also AWS Systems Manager, which is a service provided as part of EC2, where it allows you to install an agent in the operating systems you've deployed as EC2 instances and do things like patch the system automatically. It's effectively, it's an endpoint management solution, right? You can do patching, you can do configuration, and it integrates with the CloudTrail log service, which also lets you gather logs from your instances and essentially store them in S3.
Okay. The next requirement here, 7 and 8, they are intertwined pretty tightly in my opinion, which are basically your identity and access management requirements. Yeah, 7 focuses more on role-based access control, where 8 focuses more on
technical access control, the specifics around protecting credentials and that kind of stuff.
Correct.
Yeah. So AWS obviously provides identity and access management. It's how you control access to AWS resources themselves. You can set up roles and groups and demonstrate robust access there. It supports, there's the directory service, which is an actual Microsoft Active Directory running in AWS that you can use for doing the same kind of role-based access. You can even federate IAM itself with directory services or external identity providers for integrating to on-premise SSL solutions. They also provide the Cognito service, which provides identity and access management, or identity management at least, for mobile applications. So you can do the same thing there if you have a mobile app that needs to be in scope for PCI compliance.
All right.
So yeah, so requirement 8, like we said, is technical control. So this is things like password strength and account lockouts and that kind of stuff. The built-in services don't necessarily support all the specific requirements you need to meet 8, like invalid logon attempts, lockout durations, and that kind of stuff. You can use AWS Directory Service, that actual AD instance. It's based on 2012 version of AD and fine-grained password policies to apply most of that stuff to the users in your environment. A couple of caveats there have to do with implementation. the managed directory service, you have access, delegated access to a specific organizational unit within the directory, but you don't have the ability to link policies to domain controllers OU or the forest root or the domain root. So that limits and changes how you have to implement those policies in order to do so in a compliant fashion, something to keep in mind. You can always host your own directory in AWS if you don't want to use their service, or link with an external provider to meet those specific requirements if you need to. Oh, and it's worth noting that Cognito doesn't really allow you to do a whole lot in terms of password requirements. So it can be identity, that's what I mentioned before, it can be identity service for mobile stuff, but if you need your mobile app itself to be PCI compliant, then you might need to implement some additional password-related controls either in the application code or via a different IAM provider.
Okay.
Requirements simple.
Yep.
Amazon secures their physical infrastructure, the stuff that all of their services are built on. You have to secure your own media and your own physical infrastructure. For most part in PCI, this relates a lot to any media that data you export, like backups from AWS. If you download stuff from S3 and it might include cardholder data, you have to manage it appropriately. It's not going to be compliant once you take it out of the cloud, right?
Yeah, I mean, basically what it comes down to is if your cardholder data environment is using AWS as the back end, but you've got on-prem endpoints, that is your responsibility, and the stuff in the cloud is their responsibility from a physical security perspective. A good example would be a new service we're pretty excited they brought into scope, and I think could be a real game changer in the customer service space, is Amazon Connect, which is really their call center as a service platform. If you are using that as your back end, you're going to be really reducing your compliance responsibilities because it's covered by their Attestation of Compliance this year. However, of course, your customer service reps that are connecting to it from your call centers, the infrastructure they're on, the physical security around that, that's still going to be your responsibility.
Yeah, one of those common things we see a lot with call centers that take PCI or take cards over the phone, like for payments or whatever, is you got to remember that phone itself. That phone is a CDE device, right? Because that's usually as farthest out as you can get any encrypted communication related to phone. Because at some point you have to be able to talk to the person in the clear, right?
That's right.
This is also the one that covers, just for reference, if you've got POI devices, if you've got like card swipers and that kind of stuff, those physical devices have to be tracked and maintained as part of this requirement. That's obviously not something Amazon's going to do for you.
That's right. Okay, requirement 10 is effectively the security operations, your SOC, if you will. So it's log management, log monitoring. And so we touched on earlier CloudTrail, which is effectively their syslog implementation. It's very robust and extensible and can be used to log almost every action that could occur.
Yeah, pretty much every API call within AWS, or every API call that underlies the link you click on in the management console or anything else, all generate CloudTrail logs. So all of that data can get stored in an S3 bucket that you delegate, or designate, one of those words, for storing the log data. They also supply a CloudTrail logging client that you can install in supported instances, supported operating systems in your instances for gathering up operating system logs like Windows event logs, syslog off your Linux boxes, that kind of stuff, and actually pulling that stuff into CloudTrail. So that's going to be a handy way of meeting that kind of stuff. So that last bullet point is worth talking about. PCI specifically requires, it's requirement 10.4, that you have a managed, configured infrastructure to ensure that time synchronization across all of your devices that will generate logs is consistent. This is because if you're going to use that logging data to investigate events, to track activity, you have to be able to correlate events in order to build an accurate picture of what's going on. This is typical SecOps, right? So AWS, by default, AWS Linux instances are pre-configured to use Amazon's NTP pool system. So Amazon participates as part of ntp.org's pool servers. They provide a suite that their stuff points to. If you don't want to use their pool services, or you've got other instances configured, you need to make sure that they're all set up to time sync against at least the same time source, preferably an external and publicly trusted source, right? So if you're going to use their pool servers, you can configure all your systems to point to the pool servers. If you're going to use a different set of NT pool servers, or point them at USNO directly, which the Navy doesn't really like very much, or whatever your other time server is, if you got an on-premise thing where you've got your own radio clock or something, that's all great, but it is something you still have to do. Now, one of the things that you can do to help along those lines is when you build your custom virtual private clouds within AWS and you build out your subnets within those, you also can specify DHCP options related to those subnets, and that can include specifying the NTP server for all of your hosts or all the instances that you're going to launch into those networks. So you can do that to make it easier the same way that you would use DHCP scope options on premise to configure those kind of features. You just have to make sure you actually do it. It's not going to be done for you.
Okay, requirement 11 is another one of the bit of a catch-all type of requirement here. It has testing for rogue wireless access point. It has vulnerability scanning. It has the penetration testing requirement. It requires intrusion detection, or more preferably, in my opinion, intrusion prevention. Yep. And finally, it requires file integrity monitoring. So those are the 5 components there, all kind of looped together into requirement 11.
Yeah. So if you're fully hosted in AWS, they cover the rogue AP detection piece, so 11.1. If you're fully hosted, if you still have on-premise stuff that's in scope of your assessment, you still need to do that for your physical facilities.
The same goes for the vuln scanning and the pen testing of their underlying infrastructure.
Right.
The vuln scanning and pen testing of your environments that you are deploying and managing within your VPCs is fully your responsibility.
Right. And you can do, so the terms of service for AWS allow you to do vulnerability scans and some pen testing within your own environment. And I say some because certain AWS services you can't really be poking. In other words, other than EC2 instances and RDS instances, you're not supposed to be pen testing Redshift, for example. What you can also vulnerability scan and pen test the external endpoints for your environment, provided you get AWS's permission first. And the reason here primarily is that if they just see what looks like malicious activity targeting AWS endpoints and they didn't expect it, they're going to blacklist the source. So whoever's doing your testing will lose the ability to do so. If you're doing your own testing, like for pen testing, you might lose the ability to get to AWS entirely because their security folks are on the ball and they will respond quickly. So you need to let them know ahead of time if you're going to be doing that testing. It's also required under your terms of service. So there's definitely a legal commitment there, but I think the operational impact is probably should hit home for most people real quick.
And I would just add too, in regards to the penetration testing and more specifically with vulnerability scanning, this is a bit of a side about PCI in general. There was a subtle change to the language for vulnerability scanning in PCI DSS version 3.2, which we've been auditing against this year primarily, depending on what your annual audit cycle looks like, last year as well, where they require organizational independence for vulnerability scanning, which they did not explicitly in the past. And so if you're a small shop and your sysadmins or network admins were running Nessus or something internally, you really have to consider how you can demonstrate that they have organizational independence if they're scanning their own boxes effectively.
And so this is an oversight-related requirement, and basically what they're trying to prevent is you can't be checking your own work. If you're the one responsible for administering, remediating security issues with the system, you can't also be the one claiming that you did so, right? They need some kind of independent verification that things really are being done as documented and as they should be according to best practices and propriety.
Yeah, and so they've always required that for the penetration testing as well as having the specific skills, which are a little bit more specialized, so therefore pen testing is much more commonly outsourced. That's really not the case with vuln scanning because the actual operation of vuln scanners is not super difficult, of course, and you have to do it on a regular basis, and it's a pretty standard operating procedure for most IT shops. Just something to keep in mind. But let's move on in the interest of time. To requirement 12, which is basically your security governance policy and procedures requirements. Amazon has them for all of their stuff, of course, as part of their audit. They have nothing for you. You're on your own, so you need to write your own security policy. You need to conduct your own risk assessment. You need to define your own security responsibilities. You need to manage your service providers. You need to conduct your own security awareness. All of those sub-aspects of requirement 12, you're on your own for.
And that includes incident response, especially is a big one for PCI. You need to have an incident response plan. You need to include whatever the requirements for the card brands are. AWS won't do that for you. They will assist you with part of it. Part of what's covered by their AOC is if you had a breach and you need, underlying forensics and that kind of stuff, then whoever's doing the forensic investigation as delegated by Visa really is going to have to work with AWS on your behalf, and AWS will certainly do those things for you, but or will work with you and your forensics team on that, but they don't own the processes, nor are they responsible for your data. You are.
And I would just add that incident response in security operations, in my experience, is one of the more common afterthoughts of many organizations when I'm performing audit work, and so they might be meeting the specific requirements, but from a risk-based perspective, which as an auditor, obviously I'm not there to evaluate risk, I'm there to evaluate compliance, but certainly as a trusted professional, I certainly provide my opinion to those that are interested in the interest of helping them. A lot of times there's opportunity to improve incident handling, incident monitoring, security operations beyond the baseline that PCI requires. In my opinion, it's one of the most critical aspects of any security program, because at the end of the day, if anything fails, that's how you're going to find out. And if you're really not diligent there, then your policy is not going to stop dwell time.
Well, for what it's worth, that goes to disaster recovery and business continuity too. Those should never be afterthoughts, because if you ever need them, then it's already the worst case scenario. Don't wait until the last minute for those. And for what it's worth, while we're talking about this, because it is a PCI requirement, don't just have an IRP, test it at least once a year. If you don't have cause to exercise that plan, in other words, you haven't had an actual incident, you still have to at least tabletop it or test the incident response plan once a year and document and demonstrate that test in order to be compliant with requirement 1210.
Yep, and that's my point. I mean, take that to heart. You really, the return on investment, if you actually have a real situation, is huge if you conduct a legitimate, really thoughtful incident response plan test versus a trivial exercise where you're zipping through it and documenting it in an email or something.
Being able to actually have and execute that plan too is one of the things, and this is a little away from PCI, but given the climate in the news recently, this is worth pointing out. If your folks know how to execute the plan, there's not going to be the kind of embarrassing delays that lead to problems. It won't, your incident and your response to that incident won't itself become a PR problem if your folks know what the plan is and can actually execute the plan. That's so critically important, and it comes up not just with PCI. When we do audits and assessments, or even a lot of the vCISO work, and I'm working with folks out there, we spend a lot of time working on IRPs and making sure folks know how to do it, and it's one of those things that it's boring, nobody wants to do it at first, but when there's an incident, everybody's grateful that they can run the plan, and more importantly, that they know what to do and what to expect.
That's right. Okay, so let's see here. The last few appendices here in the DSS is they have some additional PCI DSS requirements for shared hosting providers. So if you are providing some type of software platform as a service offering that you're hosting in AWS, there's
multi-tenant hosting where you've got multiple customers on the same actual platform where they could potentially step on each other and that kind of stuff. PCI requires you put mechanisms in place to keep customer data and customer operations and customer activity at like the process level separate from each other. And
so the segmentation technologies we talked about that you would use in your own environment can be extended here. Then we already touched on the requirements for sunsetting SSL and early TLS. Designated entities, these are basically if you've been evaluated by the card brands to be systemically important to the payment card infrastructure.
Or you've had a major breach in the past and have been told you're a designated entity by Visa, MasterCard, Discover, JCB, or Amex, then these requirements apply to you. Amazon has, most of the designated entity stuff is about PCI program oversight and demonstrating, having somebody responsible, making sure that you're doing everything you should and continually monitoring compliance. But there's some AWS services that can help generate that evidence. Things like config and config rules we talked about before, CloudTrail logs, CloudWatch alerts for things like change detection, event monitoring. That includes that CloudTrail log agent and the systems management or systems manager clients that we talked about related to EC2 management.
So, I would just simply say here, this tends to be a preview area for things that are going to get baked into the DSS in the future, in my opinion. This is about making compliance a business as usual activity instead of what it sadly tends to be as an annual exercise with maybe a few quarterly check-ins. Right. I see them starting to align with ISO and the ISMS requirements in that regard.
Yeah, continual compliance.
That's right.
All right, so we're going to go through the reference architectures real quick. Most of this, if you're already in AWS, are going to be things that aren't going to be alien to you. Most of them are going to be familiar, but we're going to talk about sort of the key features of these in real quick fashion so we can get to the questions and answering some stuff at the end of the.
And these are documented in the workbook in great detail. And effectively what these are is 3 common architectures that would be a baseline deployment for a cardholder data environment in AWS. And I would just say, I mentioned earlier, we're really excited to be launching in the AWS marketplace our CloudFormation deployment templates for these architectures. So we've had many clients build these from scratch using the workbook, and of course you can continue to do so, but we've now automated that process, and that's available as a product in the marketplace here in tandem with reInvent. You'll see that go live. But let's quickly talk about the 3 main reference architectures we have.
Yeah, so this one is all built within one VPC. There are separate subnets that comprise an internal CDE, a DMZ CDE for like a web-based payment application, and a separate management network that includes things like where you manage antivirus, identity, and access management like directory services and stuff. The important thing to note here is this is a fully hosted AWS environment that can be PCI compliant, and an important thing to notice that jump box is in the management network. It would be in scope for assessment there, but not part of the CDE itself. And that's a common mistake people make when they use jump boxes to access CDEs, putting the jump box itself in the CDE.
Correct.
And that's a mistake because that means if you connect to the jump box, like from your laptop, from Starbucks, well, your laptop's now an in-scope device and subject to all the rest of the requirements.
That's right.
So
this is one you'll see the CloudFormation product in the marketplace that basically is your e-commerce in a box type of product there. And so this just describes what we talked about here. The entire environment is in scope and it's fully hosted in AWS.
Right. So this is just a step further from that previous one where we've created some stuff that's out of scope. So that's a separate VPC. So remember, VPCs are isolated networks from each other, so there's that built-in segmentation for you. Stuff that's not in scope for compliance is in those green subnets on the VPC on the left. The VPC on the right is all of the stuff that we just talked about related to the previous one. So that internal CE contain whatever instances that you're using that store or process, handle, or otherwise touch cardholder data like RDS and Redshift and all that. You've got the DMZ stuff for public facing things, and you've got the management, which is where your jump box, Navy, and all that other stuff.
Basically, we're showing how you would deploy a test environment of your e-commerce environment in a separate VPC.
Right.
To take it out of scope would be the common use case here.
Or anything unrelated to PCI compliance.
Of course,
if you want to use AWS for stuff outside your payment stuff, you can. You just got to split them apart that way.
And so this just describes what we discussed, and the real key is having the separate VPCs there.
So this one's infinitely, it's a lot more complicated than the previous two, and this is what I see as a more traditional deployment or more common deployment.
The hybrid.
Yeah, it extends your on-premise infrastructure into AWS and shows how you can still do it in a PCI compliant fashion. So you still have your dedicated VPCs for CDE. For CDE, we created a separate one for in-scope systems, and we created a third one for out-of-scope stuff, and you can see how like there's a VPN connection between in-scope on-premise stuff for allow communication and stuff with the CDE that's hosted in AWS, but it doesn't necessarily drag everything else into scope based on how segmentation is done. This is really just to demonstrate that it's possible. The workbook has a lot more details on how this is built and how you maintain the segmentation, but this is often what I see as a common deployment because not every company runs just a single payment application and that's all they do, right? You've got other infrastructure and other things you're responsible for, things unrelated to compliance or PCI stuff that you just have to be able to deal with, and this shows how it is absolutely possible.
Let me just address a question that we had here in our remaining time as it pertains to this slide particularly is what is one of the most common errors that we see in our work evaluating AWS deployments or AWS architecture designs? And in my opinion, it's with the hybrid architectures where there is connectivity to the CDE from the on-premise environment without an appreciation for the segmentation of the on-premise networks to the cardholder data environment. So for example, I'll see a point-to-point VPN from the corporate LAN right into the CDE without appropriate access control, basically sucking the entire corporate network into scope.
Yeah. So if you'll note here on the corporate network side, there's the out-of-scope stuff and an in-premise. In other words, we're assuming that segmentation to isolate those systems has already been done on the corporate side, which is why the VPN goes from the on-premise in-scope network to the CDE.
That's right.
Those networks connect directly to each other, but there's a router and a firewall between the out-of-scope stuff and the in-scope stuff, and that's necessary to ensure that segmentation.
Yeah, the error that we often see is that even the left side out-of-scope on-premise network would be routed right through the VPN without any segmentation into the CDE, and that's not the intent, of course, of the segmentation. And So a couple third-party solutions here. We talked about the AMIs. We sell the hardened images in the marketplace. You could buy some of these commercial products here.
Yeah, just about everybody that you're already familiar with, pretty much all security tech that you already deploys a device in your environment, there's AMIs in AWS that can help speed your deployment in the cloud.
Particularly to cover some of these technologies that are just not natively supported. Let's see. So we talked about how you get the documentation from Artifact now, and making sure that you are documenting and managing your environment. This is something, you start with the design and then the implementation. Oh, we might have just killed there. Sorry. Well, we're about out of time in any case. Some technical considerations, naming conventions. There's a lot of tagging that it supports. I think that's an important thing to be.
Yeah, you can tag pretty much every resource in AWS, which will make it really easy to identify PCI resources from non-PCI resources. Most people use it for tracking, who's responsible for billing for what applications, but you can use it for a lot more than that within AWS. Definitely leverage it as much as possible.
Okay. This whole slideshow will be available online, as will the updated workbook and the CloudFormation templates in the marketplace. We'll address all the questions that we didn't have time for as well offline. We do appreciate everyone's time here. There's just a little bit more on audit preparation, which is pretty standard operating procedure, AWS or otherwise. And that's really it. So we covered the main points we wanted to talk about today. We appreciate everyone's time. And again, any questions that you may not have already provided to us, don't hesitate to reach out to us directly through our website. There's many mechanisms to contact us directly, and here it is as well. So appreciate everyone's time. Thank you for attending, and have a nice rest of your day.